Episode 5, Building, Architecture, and Implementation. We've explored the tools. We've learned the technologies. Now it's time to build. Today, we go from theory to practice. Welcome to Episode 5 of the Open Source AI Stack 2025. We are so close to the finish line, and this episode is all about bringing everything together. For 4 episodes, we've been building knowledge piece by piece. Front-end frameworks, orchestration engines, embeddings and RAG, vector databases, LLMs and training. But how do they actually connect? Today, we're looking at complete architectures, how data flows from user to UI, to orchestration, to retrieval, to LLM and back. I'm showing you real-world use cases, chatbots, document analysis, code assistance, content generation. We're doing a quick start guide. We're writing actual code. We're deploying to production. And we're covering best practices learned from real deployments. This is the hands-on, practical episode. By the end, you'll be ready to build your first AI application. Let's code. Architecture overview. Let's step back and see how all these layers work together in a complete architecture. At the top, we have the user interface. This is where your users interact. Below that, the front-end layer handles the presentation, whether it's Next.js, Streamlit, or another framework. The orchestration layer coordinates everything. LangGraph for Crew AI manages the flow, deciding when to retrieve information, when to call the LLM, and when to return results. On the left, we have the RAG pathway. Llama Index retrieves relevant information from your vector database. That's Kubernetes storing your embeddings. On the right, the API layer uses vLLM or Ollama to serve the LLM. That's where Llama 3.3 lives. Below, we have data storage with PostgreSQL for structured data. And at the foundation, PyTorch handles any training or fine-tuning needs. Data flows from user to front-end through orchestration, accessing both embeddings and LLMs, all supported by storage and training infrastructure. It's a beautifully orchestrated symphony of components. Use cases. Now let's talk real-world use cases. How do you actually use this stack? For chatbots and assistants, combine Streamlit, LangGraph, Ollama, and ChromaDB. Build conversational AI that understands context, retrieves information, and maintains conversation history. This stack can handle customer support, internal knowledge bases, or personal assistance. Document analysis? Use Next.js, Llama Index, Kubernetes, and Llama 3.3. Process and analyze large document collections with semantic search and question answering. Legal research, medical literature review, technical documentation all become searchable and analyzable. Building a code assistant? Gradio with Qwen 2.5 and FastAPI creates intelligent coding tools that understand multiple programming languages. Context-aware suggestions, code explanation, bug detection. It's like having a senior developer as your co-pilot. For content generation, use Reflex, Crew AI, Mistral, and PostgreSQL. Create multi-agent systems where agents generate, review, and optimize content with feedback loops. Blog posts, marketing copy, technical documentation, all can be enhanced with AI. Each use case combines layers strategically to solve specific problems. Performance comparison. Let's compare models with hard data. Llama 3.3 70B offers 70 billion parameters with a 128K context length. Multilingual support and general-purpose excellence make it your default choice. Qwen 2.5 72B matches that with 72 billion parameters, also 128K context, but supports 29+ languages explicitly. The coding and multilingual performance is exceptional. DeepSeek v3 is the outlier, 671 billion total parameters, but only 37 billion activated per token. This MOE architecture gives you complex reasoning with efficiency. It's perfect for scenarios where you need maximum intelligence with reasonable compute costs. Mistral Small 24B drops to 24 billion parameters and 32K context, but the trade-off is speed. Fast inference makes it perfect for production where latency matters. 514B is your efficiency champion at just 14 billion parameters. Excellent for math and coding despite its size. The MIT license adds to its appeal. Gemma 227B rounds out the options with safety focus and efficient architecture. The 8K context is smaller, but sufficient for many use cases.
Choose based on your requirements: compute availability, language needs, context requirements, and specific task performance. Quick Start Guide. Ready to build your first AI application? Let me give you a quick start guide. Step 1. Choose your stack. For a simple RAG application, I recommend Streamlit for the front end. It's Python only and perfect for rapid prototyping. LangGraph for orchestration gives you structured workflows. Nomic Embed v2 for embeddings is the best open source option. ChromaDB as your vector database is lightweight and embedded. And Ollama with Llama 3.38b gives you local, free LLM access. Step 2. Installation. First, install Ollama with a single curl command, then pull the Llama 3.38b model. For Python dependencies, just pip install Streamlit, LangGraph, ChromaDB, and Nomic. That's it. Step 3. Run your first app. Create your app.py file, run Streamlit run app.py, and it opens at localhost 8501. You now have a functional AI application running entirely on your machine. The barrier to entry has never been lower. You can go from zero to a working AI application in under an hour. Code example. Let me show you how simple this can be. Here's a minimal RAG implementation in about 20 lines of code. Import your dependencies, Streamlit for the UI, Ollama for the LLM, embeddings from GPT-4All, ChromaDB for the vector store, and Retrieval QA for the RAG chain. Initialize your components. Create an Ollama instance with Llama 3.38b, set up your embeddings, initialize ChromaDB as your vector store. Create the RAG chain using Retrieval QA, connecting your LLM with your vector store's retriever. Set return source documents to true so you can show users where information came from. For the UI, create a Streamlit title and a text input for the query. When the user enters a query, run it through your RAG chain and display the result. That's it. This 20-line example creates a fully functional RAG system with local LLM inference, vector search, a web interface, and zero API costs. You can expand this foundation into sophisticated applications, but the core is beautifully simple. Best practices. Now let me share some best practices I've learned from production deployments. First, start simple. Don't overcomplicate your initial setup. Ollama plus ChromaDB can handle most prototypes. Add complexity only when you actually need it. I've seen too many projects fail because they tried to build the perfect system from day one. Second, monitor everything. Use Langsmith or similar tools to track LLM calls, latency, and costs. You can't optimize what you don't measure. Understanding your usage patterns is crucial for optimization. Third, implement guardrails. Add input validation, output filtering, and rate limiting. Use tools like Nemo Guardrails or LlamaGuard. AI systems can produce unexpected outputs. Be prepared. Fourth, test rigorously. Create evaluation data sets. Use frameworks like DeepEval or Ragus to measure RAG performance automatically. Manual testing doesn't scale. Fifth, cache aggressively. Cache embeddings, LLM responses, retrieve documents. Use Redis or GPT cache. This reduces costs and latency dramatically. A 90% cache hit rate is achievable. Sixth, scale gradually. Start local, move to dedicated servers, then consider distributed systems. Use Docker and Kubernetes for containerization when you're ready. Slide 25. Common pitfalls. Let me help you avoid common pitfalls that trip up many developers. First pitfall, context window overflow. Don't stuff too much into the context. Use intelligent chunking and retrieval. Remember, more context doesn't equal better results. It often leads to diluted attention. Second, ignoring prompt engineering. Generic prompts give generic results. Invest time in crafting, testing, and iterating on your prompts. This single factor can make or break your application. Third, poor chunk strategy. Chunk size matters enormously. Too small and you lose context, too large and you dilute relevance. Test 256, 512, and 1024 token sizes on your specific data. Fourth, no embedding model evaluation. Different embedding models excel at different tasks. What works for one application might fail for another. Test on your data before committing. Fifth, overlooking metadata. Store metadata with your embeddings. Source, date, author, type. This enables powerful filtering and dramatically improves results. Learn from others' mistakes. These pitfalls are avoidable. And that is how you build production AI applications. We've covered architecture, use cases, implementation, best practices, deployment, and monitoring. You now have the complete blueprint. Start simple with Streamlit and Llama. Build your MVP with proper orchestration. Deploy with Docker. Monitor everything. Iterate based on real usage. One episode left. In our series finale, we're looking at the future, optimizing costs and performance, securing your applications, and wrapping up with key takeaways that you'll use for years. Like this video, subscribe for the finale, and here's a challenge. Build something this week and share a screenshot in the comments. I want to see what you create. See you in the final episode.